where I said in class to everybody when they took the exam, I said, I want you guys to choose whatever question you don't want to grade to cross out. But cross it out, otherwise I'll pick what I cross out. And I had a student named Kevin, and he didn't cross one out. So I decided, okay, somebody didn't follow the instructions. I decided to grade all his questions, and I took the one with the greatest number of points and crossed that one out. And when I wrote your exam, I did it for yours as well. The Kevin rule still applies. So you need to cross out whatever question you don't want to do or you don't want to look at. Because if you don't cross something out, I will choose to cross out whichever ones I got the highest number of points. I'm serious. I want you to make the decision on what to cross out. Does that make sense? Okay. So what's the best technique? The best technique is you scan, identify which one you don't even want to start because it's time constrained. I think that'd be the best. That's just my suggestion. And you guys, you know what it's all about in terms of test taking, right? You've got to deal with the time management. Don't sit there and concentrate and focus with tunnel vision on one question for an hour. You don't have much time.
Say we have like one giant multi-part question like this. We could just cross that one out?
Heck no. This one's so straightforward. I think in this particular example, there's certainly no equilibrium solutions, but let's talk about the existence and uniqueness. So let's dive into part 2. Ready? Are you willing?
There are equilibrium.
So you're not ready, because I don't think I can skip number 1. I think there are some equilibrium solutions. And I think clearly the equilibrium solutions are y equals
0 and y equals 2.
So nothing to show there, right? But I do think I can talk about part 2. Are they unique? Well, here's how I find out. If I think of y prime as equaling all the garbage above my brace, which in turn ends up being a function in x and y, well, potentially a function in as many as 2 variables x and y. I know in this example I got lucky. It's only a function in terms of y, but it could be in terms of both x and y. So question, is this function continuous everywhere?
Yes.
Yeah, so in particular it's continuous about any point whose y coordinate is 0, 2. But I think the partial of f with respect to y is some polynomial, actually just linear in y, which clearly is continuous everywhere. So I think for free, I shouldn't say for free. I think by the existence of uniqueness there, these equilibrium solutions are unique. What does it mean graphically speaking? What does it mean graphically speaking?
Nothing crosses.
Nothing crosses these two solutions. These really are solutions to my DE. The two horizontal lines, y equals 0 and y equals 2. It's just no other solution passed through any point on those two curves. What if a curve gets close to it? Then what's going to happen? There would be an asymptotic, thank you. The closer and closer, there would be an asymptotic relationship between the curve and those lines. I agree. Got it? So far, so good?
Okay, so where you say justify your answer, what exactly would you want us to write?
Sorry, you already asked that.
Yeah.
I didn't answer your question. I'm just in this habit of trying to beat the clock. I apologize.
I know, I just don't want to get marked down on like
So
grammar. Yeah.
You know what? You guys, I don't think I've used this notation for you guys in class. I apologize. I think
Yeah.
I've been using this notation.
Oh. No, you haven't. You've been using the other notation.
Have I really?
Yes. Yeah.
Well, I hate to call it delta, but yeah, the other
What is it? Isn't it a lowercase delta? The little squiggly d?
Well, delta's this,
Oh.
and I've been
that's
using
right.
this.
Yeah.
I've heard del.
Well, what's
Yeah. What is it?
what's the
what do you call
squiggly
that?
D?
Was it you, Randall? Randall was asking me the same question the other day, and I was saying, I have no clue. I've never called it anything.
Fancy.
I went online, check, and most sites say they won't even deal with it. They'll just refer to it simply using for partial differentiation, which is what I say. I did find one website that did call it del, but that makes me really nervous because I use this symbol for del operator. For those who have not taken Math 32, I'm not making any sense. It's a vector valued operator in a multivariable calculus. And I can see why you call it del, because technically speaking, this is an upside delta. I think that's where the word del comes from. But lowercase delta is that one. You flip it, you don't get that. So I really disagree emphatically with calling this thing del. I think we should call it nothing. It's just a symbol I use for partial differentiation.
Can we call it squiggly D?
Squiggly D.
Okay.
That's a little better.
All right.
I mean, I suppose some people would say some kind of version of the letter rho from the Greek alphabet, at least a lowercase letter, but, you know, rho looks like this. I admit it's the same thing, but rotated 180 degrees, and with that rotation,
Just call it a partial row.
partial rho? Confused rho?
Just a partial.
Ambidextrous rho? So you guys, Brad, I need to stop
Okay.
a minute. Clearly, these two are continuous everywhere. Therefore, all solutions my two equilibrium solutions in particular are unique.
Okay.
I think that would be clear writing, so someone like me who's really, really groggy late at night grading their papers would say, yeah, I'm okay with that.
Can you skip down to the final?
Yes, I can.
One.
First, Chris?
But when we say a solution is unique, that simply means that any point within that solution is not part of another solution, right?
That's a good way to put it. I would have phrased that as saying, through a given point, there's only one solution to the DE. Same thing. What?
Just wondering, go over section 11, question 15.
I certainly will. Can I finish up the real quick though? So number 15. Got it. And I do not know what's coming next. Hold it. Y times y minus 2. Y times y minus 2. So, looks to me like it's my job to come up with some isoclines. And I think in this example, it's simply going to be y equals 1. But I maintain when y prime is equal to 0, I get two solutions. Or, excuse me, two isoclines, this one and this one. I think when y is equal to 3, I get y equals 3 and y equals 1. No, I think it's negative 1. Impossible. And I think when it's 8, instead of y is negative 2, and y is positive. You guys mind me doing my math deep that fast?
Yeah. Actually, the only thing I really needed to know, or was wondering about, was the concavity. Because, I mean, the graphing the isoclines, that's all easy. But discuss concavity for solutions, then we just find the second order derivative.
Yeah, you're done.
But when you say discuss, that's what's kind of making me think you want me to put it in writing.
Oh, sure.
So how would you want that written?
Is that okay?
Yeah.
Everybody?
Yeah.
Everybody, come on.
No.
Yes.
It's no, it's not okay. Because y is a function of x. Chain rule. Chain rule.
What do you have?
My poor pen's drying out.
Oh, it
I
is.
heard that.
Okay.
Let's clean up. Does that mean I can pull out a 2, I can pull out a y prime, and a y's left over? But that means I got 2 times y's twice times y minus 2. Did I just make a mistake?
You did.
Yeah.
I'm sorry, I really did make a math D mistake. When I pulled out the 2 and the y prime, this is not what's left over, but this is. My apologies. Math D again? So if I have a solution above the equilibrium solution y equals 2, every solution above that equilibrium solution has upward concavity. I think every solution between the line y equals 1 and the equilibrium solution y equals 2 has downward concavity. I think every solution between the equilibrium solution y equals 0 and the line y equals 1 has upward concavity, or at least a portion of such a solution. And every solution below the horizontal x-axis has downward concavity.
And so You want us to write a sentence explaining that?
Yeah, the words I just read.
Okay, just what you said?
Yeah,
Okay,
that's what I said.
all right.
You guys okay with that?
Yeah.
If so, let's go back. Not there. Actually, there. Actually, you guys, since I've already got this stuff, before I do number 15, can I just scan through this and I can identify what examples are not pertinent for your exam?
Yes.
This is 2007. I'm worried. I posted this online, but I did it as fast as I could. I did not look at it.
One of them's 2004.
And that's so far back, you guys. It was different edition of the book. And you guys are probably aware that different editions are kind of silly. With this book, it's not. As I recall, the second edition was dramatically different. So I do want to take a brief moment with you guys, since I haven't had any time. I've been so busy. Let me take a peek and see what's in this example. So I certainly like number 1. Oh, jeepers.
Oh, yeah, there we go. Solve this differential equation analytically given that the solution passes through the point 03.
What about it?
What? What do you do there?
Is it just
That's,
the
yeah.
same stuff we've been doing? Like one
Oh, there's a lot more to this problem, yeah.
Well, I was just putting things together. When you saw this in the homework set,
Yeah,
you didn't know how to solve DEs.
yeah.
Now we do.
Okay.
Yeah.
Everybody?
Yeah.
Partial fraction decomposition.
Okay.
Isn't this a piece of cake?
Yeah.
No. My gosh, it's like a 4-liner. Oh, you guys mock me. I don't know. How do you solve for 1? Oh shoot, my glasses are off.
Well, you have a y there, but if you scroll down, doesn't it give you a point value for y and x?
Yeah.
My apologies. So
Yeah.
you're saying as I can use an additional value condition.
Yeah.
0, 3.
Well, it should give you a y and an x, so
Wait a
I'm
minute, everybody.
not really sure what it was again, but
I just made a mistake. I really did. When I answer differentiate with respect to x, what do I get? I'm not sure what I was thinking going through my head. My apologies. Yes, maybe so. Actually, I was thinking of constant proportionality, so I really thinking of it. But you know what? I am going to take a break, Bradley, like you suggested.
Yeah.
Because y evaluated 0 is equal to 3, I guess it necessarily implies that 3 is equal to, my goodness, was I that nice with these numbers? C1. So I guess y over y minus, I can't, 2 is equal to 3ex.
yep.
Gee, that took how many minutes? 1.5. Not bad.
Okay.
But you see my point, Brad? I just
Yeah.
wanted to solve the E.
Okay.
Well, you guys, let me take a peek. Is this okay spending time doing this or not? I don't want to waste your time.
Yes,
Yeah.
definitely.
Definitely.
So number 2, actually, can you guys talk a little bit? Look at number 2. That screams out done. That screams out done. Separation of variables technique. And jeepers, when it comes to the integral on the right-hand side of the equal sign, that's way too simplistic,
So-
isn't it? Just factor by proof. You don't even have to use the you don't even have to use the
Would you actually throw in a cosine hyperbolic?
How do you
yeah, because at least that's only e to the y plus e to the negative y over 2.
Okay, so I should do some flashcards tonight. You're saying
Yeah, just the basics, the real basics.
the basics, cosine, sines, all that. Okay.
And by the way, in terms of x, what integration technique do you use on the right-hand side?
That's the point.
partial fraction decomposition.
For which one?
For the integral on the right-hand side involving x's.
Yes. On the left.
You mean the right hand separated, right?
Isn't that what it said?
You just said the right hand side.
Yeah, so right-hand side, after you separate variables, that's what I
Yeah,
meant.
2 over X, Y.
What about number 3? When you separate, what do you get on the right-hand side? You're not gonna separate, this is a
That one's,
Bernoulli.
yeah, Bernoulli.
And after you make your substitution, will it be separable?
What is your?
Oh, no.
No,
What's
it'll
your
be,
integrated?
You have to use a U sub.
it'll be, I know, but after the U sub with the Bernoulli U sub, the DE transforms into one that is
First order linear.
That means you're gonna be using a
Integrating factor.
Nice. You tell me if I'm saying this too fast. What about number 4? Only because what I see.
That
is
would be,
parentheses, both
exact.
T's, nasty powers. It looks like.
Exact.
It does look like it. I hope it's not. I hope you have to finagle it.
Can you do that one?
That doesn't look
I don't mind doing it, but
Finaglable?
Just look at this real quick.
Is that a real word?
What's the real word?
Finaglable?
Finagleability.
Sounds a little awkward to me. but-
Finaglability, that's a good one. Test for finaglability.
Okay, guys, here it is, number 5. This is what I was afraid of. With number 5,
Good.
you're gonna have to drop that one.
Wait, it's my second order. It's my second order.
It's a second order linear DE,
Okay.
but it involves both a dependent and independent variable. We have not discussed that, and we will not discuss it for a while, for another 2 chapters. I think in the second part, don't answer number 1 either. Clearly, number 2 screams out at you that it's,
Separable.
hold on.
Wait, no, that's not separable. That's the one where you gotta change the y's, so
Oh, it does work.
homogeneous?
It's nothing more than
Homogeneous?
homogeneous.
Yeah.
How much of this was 128?
So you would look at number 4?
Yeah.
Oh, come on.
Which one's homogeneous? Number 3.
I cannot read that at all. Gee,
We'll read it for you.
do you mind? I would really
It's
appreciate it.
2x
So n is
squared.
what?
2x squared.
Times e to the x squared plus y,
Yeah.
plus 1 minus 2x squared times y. That's right.
And n is,
X times e to the x squared plus y
Minus X over 1.
minus x over y minus x cubed.
Yeah.
you guys, I'm sure you do not appreciate how difficult these are to write. To write, force you to use an integrating factor, and then you're able to find a potential function. And they're not easy, they're not super simple. Anyway, for me to check exactness, I'm merely going to dive in, take a peek at the partial of m with respect to y, just see what I get, and I get, actually, I'll be quiet.
2x squared times x squared plus y
Yeah.
Times,
e to the x squared plus y
yeah, thank you.
Yeah, X plus Y.
minus 2x squared.
I can't hear you.
Minus 2X squared.
My apologies, you're right. In my head, I'm wrong. I apologize.
John, what do we got?
I was checking it down, yes. Now, you guys, let's drop it like a rock. I think n's partial effect to x is gonna be a bit of work. Because I think with the first, I got the product wrong.
2X. Yeah.
So here's the first. Oh, you said 2x?
I was doing change.
How about the first times 3 to the second?
Yeah.
So x
2x.
E to the X squared. Plus Y.
minus 3x squared.
Can we stop for a minute? So the partial in respect to x is actually a, oh, sorry, another mistake. I was trying to combine these two. I wasn't looking at that much factor. So question, are these the same?
I don't think so.
Ah, shoot, they're not. They differ by a bit. So I think we need to come up with an integrating factor. And to come up with an integrating factor, let's take a peek at the difference between these two partials, which, by the way, ends up being the following. I'm stalling because I don't know what it is. I think this beast cancels out, and I'm merely left with an x squared plus 1 over y. Is that correct, you guys? X squared plus 1 over y. But keep in mind, you guys, I'm going to divide this either by m or by n, but in such a way that I cancel. And I'm only left with the function still in terms of one variable.
What happened to the second part of the product over n?
Where?
You did-
Thank you. I'm scanning, thinking, this isn't going to work. What did I miss?
You missed plus e to the x squared plus 1. Just by
I'm
itself.
so sorry. I was in the middle of the product rule, like you said. You said product rule. Here, I've got the first times through the second. I forgot to put in the second times through the first. It's going to change things, isn't it?
Yeah.
It's going to give me minus x to that power, or excuse me, minus e to that power. So minus e to the x squared plus y. Okay, now I'll slow down. Because I want to divide this either by m or by n and get some cancellation with variables, and everybody clearly is going to be n, isn't it? If I divide by n, let's see what happens.
Wasn't
Yes, I'm listening.
if I remember correctly, wasn't it my minus nx over n?
Yeah, that's what I wrote on the board. I just forgot to put the n specs.
Isn't it all over n though?
I know, that's why I'm not finished.
Oh, okay.
That's why I got the fraction bar.
Oh, okay.
I'm saying, which one am I going to divide by, m or
Okay.
n? I was just trying to skip a step.
Can you go back and explain how you got that M?
Yes. Can I erase it though? From scratch? Can I be honest and show you what I did in my head? Because I cheated when I wrote this on the board. I was treating this first term really as this. Sorry, you said m. I was treating this really as this. 2x squared e to the x squared e to the 1. So remember, that's just another name for e to the x squared plus y. And if I differentiate this with respect to the variable y, aren't I treating this as merely a numerical coefficient? And I get it right back. Oh, but it's a coefficient for e to the y power, but to differentiate this with respect to y, I just get e to the y right back. And then I said, jeepers, let me just call it by its original name. I'm being honest with you, that's what I did in my head. But for you, if you really want to, just immediately split up, so you don't have to think about it. And I'm not finished. To differentiate one respect to who cares what variable is gone. To differentiate this respect to y, using the product rule, what do I get? Yeah, how about nothing? I don't need to. Again, remember, I'm treating x as a constant. I just think I get the coefficient for y, which is minus 2x squared. I hope that's what I had before. Is that what But you guys, I think if I'm going to divide this, or Brad, by one or the other, let's choose n. And n is going to be, can you help me with this? X e to the power. What's the rest of it?
Minus x over y
Minus x over y?
minus x cubed.
Minus x cubed. But you guys, technically speaking,
Pull out the negative of this.
You could pull out a negative in the top.
oh, minus x over y, you said?
Yeah.
My apologies. You said, Brad, you're going to pull a negative 1.
Pull a negative out at the top, and then you'll have two. Oh well, the x is, you got a 3 in the bottom. For what? Why? Oh, okay.
Well, because you told me to.
Yeah, no, you do have a 3 in the bottom.
And downstairs, you're going to pull out.
Yep.
So you guys, I was right. Something nice does happen. Nice clean cancellation, and I'm merely left with a negative 1 over x. But since I was dividing by n, was it n or m?
N.
It was n. Since I divided by n, then I think my integrating factor in terms of the variable x is going to be e to the power of the integral of my negative 1 over x with respect to x. In other words, e to the power of the integral of f of x, no sign change. I just maintain this turns out to be a positive 1 over x. Now you guys, we don't have to finish. Can you just start me off? Can I erase this?
Yeah.
Now, you guys, you relax. You got a test tomorrow. That was contradictory, wasn't it? I didn't mean that, I do relax brain tests. What's easier to evaluate, what's easier to undo, the partial respect to X or Y? What's easier to undo? You've got a test tomorrow. I'm testing you now. You want to beat the clock, which one's easier to undo the differentiation process for?
Why?
Which one?
X.
Which one? Neither, because
Yeah, accidental.
actually multiplied by the integrating factor, that's the whole point of getting it. You guys see my point? Okay, good. So don't forget, come in and multiply by the integrating factor. Can I do it fast? Did you guys see my point? Now you can play. I can't play. I erased something. Was it there an X over Y thing here?
Yeah.
Thank you. I lost my fraction. Ah, they're both pretty easy. Doesn't make any difference.
Go with Y. So, just a notation is the book uses different notation than you do. So, where you do phi of X, is that the same as squiggly line F over squiggly D X?
Yes.
Okay.
I agree.
Cool.
And you guys, I think I just said something that's wrong. I said they both look about the same level of easiness. I take that back. You know, to undo the partial respect to X here, I guess I'd have to, at least in my head if nothing else, use integration by parts. So maybe I spoke too hastily. Maybe it really is the case that by far this is the easier one to deal with. I think I misspoke.
Let's do a sub.
Yeah, you're right, not integration by parts, but use sub. But I think I have to think a little more there. Not as that bad, I'm just saying. I think there is a difference. Michael?
So when multiplying by the integrating factor, do you only multiply it by partial respect to y in this case, or do you try it as well?
No, in fact, I'm doing a very poor job. Michael, what I really meant to say is this. You multiply both sides of the entire dE by the integrating factor. And I was just trying to save time on the board. I actually did to both these m and n's before I erased them. I multiplied both of them by 1 over x because, again, I multiplied both sides of the original dE by 1 over x. So it really is both of them. Is that okay? Oh, it looks like we're shooting today down in flames anyways, doesn't it?
So,
Wait, so
once you've integrated, or once you've multiplied, like say you chose phi y and you multiplied that by 1 over x, then you just integrate it with respect to y, or with respect to x.
Well, if it was phi sub x being equal
Yeah.
to something, I undo the differentiation by the variable x.
and then for
Okay.
sub y.
Undo the partial respect to y.
Okay.
Brad, I'm slightly nervous when you said that you said I'm going to integrate respect to x. I would rather say I'm undoing the partial different.
I'm doing the partial differentiation.
Yes.
Yeah.
So I was saying, I'm sorry, I swear I didn't concentrate.
Okay.
You said, oh, phi sub x is this stuff, let's integrate with respect to x. I'd rather say I'm undoing the partial differentiation process with respect to x.
Okay.
So I hate to write the integral.
And
all
so,
that stuff.
when you undo the partial differentiation process with respect to x, then you've got to differentiate partially with respect to y.
Yes.
Yes.
now
And
you
then
compare
that's
the
how you
original
can find
partial
your-
with respect
okay.
to y with the new partial with respect to y.
Okay. Okay.
So what do you?
I got it.
I'm all ears.
So you're taking the integral of phi of x with respect to x. So that whole expression dx.
If you insist.
Okay.
I just
Well, you're anti taking the partial. Undoing the second.
There
Until
you
you
go. I
take
like
it
the way you
with
said
partial,
that.
yeah.
Yeah, I like that a lot. I like the partial differentiation process.
Okay.
So do you see why I'm being so busy?
Yeah.
It's because I hate to write the integral symbol and I got the x's and y's in there. I mean, for those of you who are Math 32 grads, you might be thinking of, oh, actually, you're right, double integral if you're applying Green's theorem for a line integral.
Yeah.
Ooh, social anarchists in
DX,
Paraboland.
Yeah.
That's a good one. I like that one.
Okay.
For those who don't know me, sorry, I write my exams late at night. I'm tired of punching. That kind of get a little goofy. I think, ooh, I love number 2. Number 3 is as easy as on the last exam. Don't do number 4. Sorry.
Reduction.
Different book. Oh, I said reduction of order. Yeah, that's good. I like that. That screams out at me.
That's just separation of
Separation
variables.
of variables technique. On the left-hand side, the integration technique you're going to use after you separate is partial fraction
Yeah.
decomposition.
Yeah.
On the
Right side.
Separate, or
right-hand side, oh my goodness.
Integration
it's
by
not
parts.
a worthy test question, sorry. Let's skip that. Wow, this must have been a light semester.
so
This
do you
DE
do you
is
get
what?
harder every semester? Is that how it works? I mean,
Oh, no, not at all. No.
Just punishing people who relate.
That's pretty easy. It's not exactly,
Yeah.
of course, exactness. Here, clearly number 7 is Bernoulli. And after you use that, it'll transform to a linear DE, and then you're gonna make a nice clean integrating factor multiplication process to both sides. Awesome. So as of now, exam 2,
It's 1/7 population.
yes, all that.
exam 2 is not pertinent whatsoever.
Okay. When do we get into matrices? Is that
Today.
today? Okay. Wonderful.
So have you guys checked out the additional homework I put in here yesterday?
Yes.
And you guys, I went to the old exams and stuff like that and just stole these really quick. So I didn't write off from scratch. I wrote it back then. And is there anything else that we need to look at? No. This would have just great, isn't it?
Yeah.
Was there that one up there, the 1.11 number 15?
Yes, I know it's nice.
So
Yes.
you would say what we should focus on mostly is these DE techniques that we've been doing. Maybe the physical application problems.
Yes.
In particular, the populations.
Populations,
um,
tanks.
tanks, stuff like that, and graphing isochlines.
Yeah. And there are other
Yeah.
odds and ends. Existence uniqueness theorem.
Yeah.
Orthogonal trajectories. Is this a solution to a DE?
Orthogonal trajectories. Huh?
You guys, since you get the test tomorrow, you tell me.
Can we quickly do an orthogonal trajectory?
Before we do that, you tell me this.
Yeah.
Give me the techniques of integration, Professor.
Bernoulli, exact, separation of
I can't read that
variables,
fast. Exact.
separation of variables, homogeneous, first order linear.
Well, we started with some
Um,
order where one of the variables was
Yes, and we had those weird ones, the second order. They are, well, they're random, yes,
not random.
they're random.
They're very specific.
very specific and random.
My wife has teenage daughters. It took me a while to train them to use that word. So number 15, sorry. Section 111. Where I have y double prime equals omega squared y with y of 0 being equal to a and y prime of 0 being equal to 0. Where omega and a, excuse me, where omega and a are just positive constants. So, I don't know, you guys, what do I do? All right, just stare at me then. I'll come in, and I'll go ahead and give my y prime a whole new name. It just means that du dx is simply the second derivative of y with respect to x. And I think that's going to tell me that u prime is equal to omega squared times u. What's next?
You do something.
But
You
isn't
do-
u y
It should be the same times u.
Yeah, du dy should
Oh, sorry. I really made that mistake. I didn't mean that. My apologies. That y is just 1.
And then there should be,
It should be 1.
u next to u prime is,
Why?
isn't the u prime?
Are you saying I'm wrong?
representing du over dy?
Are you saying I'm wrong?
Maybe.
I'm definitely wrong. Here's why. Let me put my pen down. I won't write. Look at my notation, you guys. That u prime is derivative for u with respect to x. So in a sense, this involved x's, u's, and now I got y's. I got 3 different variables working for me. That's why I'm upset with what I wrote on the board, but I did not mean the mistake that I really did commit or convert it to a u. And so I would really like, in this situation where I do not have an independent variable, to not express u as a derivative of u in terms of the missing variable x. Not that I have anything wrong written on the board here, but if you guys don't mind with my black pen, I'll slash this, and you can see the difference when I write it correctly. Since I do have y's, I'll rewrite this derivative so it's a derivative with respect to y. By using an intermediate variable, namely the y, and I'll use a chain rule, because I think du dy times dy dx is indeed du dx. Now, and it sounds like I'm really lying to you guys, because technically speaking, I didn't really get rid of the x over here, but I can.
dx
Because I think
squared.
another name for this is just...
Wait, dx squared,
dx is equal to
dx, oh, okay.
I apparently can't talk and write today. I've been doing this all my classes. I have no idea why. I'm sorry. Just nail it for me. But don't miss the important point I just made. I'm still not happy. I still see x's. But I think I could rewrite the second factor on the left-hand side so you don't see any x whatsoever by embellishing it in that dependent variable u, because u is another name for dy dx. That y prime really represents dy dx. Oh, you guys, I'm starting to like this. I guess now things are legal, because technically speaking, another name for y double prime up there is u du dy, being equal to omega squared times 1. Do you see the difference on the left-hand side?
Yes, yes.
And by the way, when I saw this dE for u, it's understood that it would be a function not an x in terms of y, because that's my newly understood, at least temporarily, my newly understood independent variable. I've gone this far. Can I finish? I think the appropriate technique would be
separation of variables.